All right, today, lesson 31C, Intro to Exponents. And as you can see, we've done quite a few 8th grade standards as well this year because this is honors 7th grade. We have another one today. And so we end this year with the 8th grade portion of the Exponents standards. Hopefully this is going to be an easy end to the school year. It'll get a little tougher when we hit negative exponents and start mixing everything together, but should be a last easy unit for the year. So today, introduction to exponents. So let's get started. Exponential form, which you learned in the 6th grade. When we have 3 to the 4th power, we read that as exactly what I just said, 3 to the 4th power. The 3 is what we refer to as the base. And here's where we are starting to fill things in. The 4, of course, is the exponent. And 3 to the 4th power in extended, or sometimes it's called expanded, as an expanded or extended product, is 3 times 3 times 3 times 3, which we all knew that from 6th grade. And once again, we call that an extended or expanded product. And then if we're asked to simplify or evaluate it, it would evaluate to or simplify to 81. Okay? So for the first few problems here, I would like you to rewrite as extended products and then evaluate. So let's just go ahead and do number 1 and 2 for right now, which of course should take you about 10 seconds. Number 1, of course, as an extended product is 5 times 5, and that, of course, is 25. Number 2, as an extended product is 2 times 2 times 2, and that, of course, is 8. Number 3 is, of course, negative 9 times negative 9, and that is 81 when we evaluate it. And I would like you to quickly finish the rest in that block. So finish through number 8. Now as you're finishing up through number 8, I suppose the new part for this year would be the fact that we're dealing with negative bases, which you wouldn't have done last year. You would have stuck with positive bases. And you may have done some with fractional bases as long as they are positive, but you wouldn't have done any with negative bases. All right, could I get you to compare 4 through 8 with your shoulder partner? Quickly, go. All right, number 4, as an extended product, looks like that. When we evaluate that big mass, though, it is negative 300 or negative 243. Excuse me. Number 5, as an extended product, of course, should be this. And when we evaluate, it should be negative 27. Number 6. As an extended product, looks like that. Notice that I am writing the base in parentheses. Typically that's a good strategy, and I'm mentioning that because a few of you did not do that when you were writing it out. You'll see in the next block of problems why we have to pay attention to that. But in this one, when we evaluate it, we get 16 over 81. Number 7, as an extended product, looks like this. And that, of course, would be 4 over 25. And then number 8, as an extended product, looks like this. And that simplifies or evaluates to negative 27 over 343. So what I was just saying is this. Typically, if we see the base in parentheses here, good strategy is to write it as an extended product in parentheses as well. And the issue is because of signs in certain problems. We have to be careful with that sometimes. All right, so when we have something like 7 to the 2nd power, and I'm sure that you have all heard that sometimes we refer to that as 7 squared. If you didn't, we can state all powers to the 2nd power as whatever the base is squared. And we have a shortcut way of also saying to the 3rd power. So we could state this as 5 to the 3rd power, but we could also phrase it as 5 cubed. And we'll talk where those two words come from in just a second. And then when we get to powers above 3, well, then we just have to state whatever it is. So in this case, 3 to the 4th power. So y squared and y cubed. Well, the term squared comes from the area of a square. So if we have a 5 by 5 square, 5 squared, the shape of a square, is of course 25. So that's where that idea comes from. And then the same idea in 3 dimensions. If we have a cube, which when we have a cube, we should automatically know that all 3 dimensions are the same. So in this case, 5 by 5 by 5. To find the volume of that cube, the result would come from 5 cubed. So that's really where those two terms come from. The idea of finding the area of a square and the idea of finding the volume of a cube. Okay? All right. Now, exponent problems that I term as special exponent problems. Special because there's something different about them. So first of all, notice here that the base is not in parentheses. That makes this a little different than if it happened to be in parentheses. So what negative 4 to the 3rd power really means, it really means this. We can think of it as the opposite of 4 cubed. And that's how we write it out as an extended product. The opposite of 4 cubed. Well, that happens to be negative 64. And some of you might be thinking, well, what difference does it make? Well, it makes a difference depending on what the exponent is. Okay? So in negative 6 squared, or the opposite of 6 squared, that would be the opposite of 6 squared. And 6 squared is 36. So when there aren't any parentheses around that negative 6 as a base, the answer is negative. If we had something like this, though, the answer, of course, is not negative. And so that's why I call these type special exponent problems, because these kind will always have a value that is negative. This type, sometimes the value of the answer will be positive, like it is here, or sometimes it will be negative. It all depends on what the exponent is. But here, it does not matter what the exponent is. And so what I want to say to you is this. Don't get those two confused with problems like negative 4, where the negative 4 is in parentheses to the 2nd power. Don't get those two ideas mixed up because they are totally, totally different. All right. I would like all of you to do 9 through 16. Once you finish, I'll have you compare with your shoulder partner. Number 9, as an extended or expanded product should look like that, which is 49. Number 10, as an extended or expanded product, those both mean the same thing, by the way. I noticed in your notes it says expanded, but here it says extended, but they mean the same idea. We should get negative 49. Number 11, as an extended or expanded product looks like that, and we end up with negative 25. Number 12 looks like this, and then negative 729. Number 13 looks like this, and then negative 343. Number 14 looks like this, and then 64. And number 15 looks like this, and then negative 1,000. In number 16, we should end up with negative 1,000. In 17 through 24, you are not asked to evaluate. It says, without evaluating, determine if the product will be positive or negative. Let's do number 17 together. Will that be positive or negative? Negative. Negative. Good. All right, go ahead and quickly do the rest in that block. So we know that problems like number 17 will always have a negative product. However, problems like number 18 sometimes will have a positive product, sometimes they will have a negative product. How do you know? For example, is this one positive or negative? Positive. Okay, so how do you know?
If it's even.
If what's even? Because negative 10 is even, by the way.
Exponent is even.
There you go. Okay, so if the exponent is even, because you're multiplying negative 10 out an even number of times, that would leave you with a positive product. But in problems like number 17, it does not matter what the exponent is. we will always end up with a negative answer. Okay? So number 19 would be negative because of the odd power. Number 20 is negative, not because of the power, but because of the fact that the base is negative and there aren't parentheses around it. 21 is negative. 22 is negative. 23 is negative. 24 is positive. All right, so now let's take these ideas and multiply items with the same base. And so if we have 4 to the third times 4 to the second, 4 to the third means 4 times 4 times 4. 4 to the second means 4 times 4. And if we're trying to simplify this to one base and one exponent, we would simplify this to 4 to the fifth power. Now, before anybody starts over the next few days saying, yeah, but can't you just do this with the exponents? I'm not going to mention anything about rules as far as exponents go. If you discover those on your own, great. But I'm not going to be talking about rules for exponents until we're at the very end of this whole idea. And the reason is simple. I've been teaching for a long time, and as soon as we start throwing rules in, some students start to get confused and mixed up with the rules. If you discover them on your own, go for it. But I'm not going to talk about the specific rules yet. If we have 2 to the second times 2 to the fourth times 2, well, 2 to the second as an extended product is 2 times 2. 2 to the fourth as an extended product is 2 times 2 times 2 times 2. And then 2 is just 2. And so you can clearly see that this simplifies to 2 to the seventh power. So in the next block of problems, the instructions say, write in exponential form. That's exactly what we've done in these two problems. 4 to the fifth is that mess in exponential form. 2 to the seventh is that mess in exponential form. So go ahead and do number 25 through 27. I'll get back to you in about a minute. That mess in number 25, there are 8 7s, so therefore it is 7 to the 8th power. Number 26, we have 4 of the negative 2/3, and that base is in parentheses, so therefore it should be negative 2/3 in parentheses to the 4th power. Now we have this, and I can tell you there's a reason why this problem is here, and it is what I saw when I walked around. Some of you had this written down. Or, hold on, let me do this. Here's what you have written down. There's a problem with that. Anybody know what it is? Nobody knows? I know what you think. You think that this negative 1/2 that I just wrote down in purple there, you think it's that negative 1/2 to the 6th power. But when it's written like that, only the 1 has the 6th power. If you want the 6th power to be with the 2 as well, writing it without parentheses, then you would have to write it like that. So in this one, we do need to write it like this because this means the opposite of 1/2 to the 6th power. So I guess the moral here is this. When we're dealing with fractional bases, we have to use parentheses. But notice that the opposite is on the outside of the parentheses, much like it is on the outside here. So we have to be very careful with how we're dealing with this. We are not going to write it like this. We are not going to write it like this. We have to write it like this. And we're not going to write it like this either. Why can we not write it like that?
Because we have a different result in the answer.
Like what?
Being a positive or a negative number when it should be a negative number.
Right. The answer should be negative, whereas if you write it like that, that has a positive answer. Right? So it can't be written like this either. We have to write it like this. All right, so the last block of problems kind of summarizes what we just talked about. So go ahead and do the last block of problems. Rewrite each as a single base and exponent. You don't have to write out the extended or expanded product. Just rewrite it with a single base and a single exponent. So I'm not worried about problems like number 28. Obviously, that is going to be 2 to the 5th power. And I did write out the extended product, so just to show you that's why it's 2 to the 5th. Not really concerned about problems like number 29, because that's pretty easy as well. That's 3 to the 3rd, as we can see from the extended product. Not too worried about number 30 either. Writing out as an extended product, you can clearly see it as negative 2 in parentheses to the 6th power. Not too concerned about number 31. We can clearly see that that's 5 to the 11th power. However, I did see a few of you in number 32 not use parentheses around the base. Listen, one more time. If the base is a fraction, there needs to be parentheses involved. Otherwise, if you just throw an exponent off to the side, like, let me go ahead and bring up the answer first. It's 1/2 in parentheses to the 5th power. If you just write it like this, like I tried to make this point in the last problem, that exponent only goes with the 1. It does not go with the 2. And so if I asked you to multiply it out, you would not get the same answer. So please do not write it like that, because it does not mean the same thing. And then number 33, this would be negative 9 in parentheses to the 11th power. We have 11 of the negative 9s. And then number 34, another one with a fractional base. That should be 1/4 in parentheses to the 9th power. All right, we are finished for today.